everyone, welcome to the Great Edge Workshop. Something different for you today. We're looking at the perks and perils of Class 2 electrical appliances. If you're not familiar with what Class 2 appliances are, it means that the live conductors, so line and neutral, are double insulated in a way that extraneous parts, particularly if they're made of metal, can't become live. So Class 1 appliance, like a metal toaster for example, the outer casing of it needs to be connected to earth so that there isn't a chance for a voltage potential to develop on it. And if you were to touch it, it could become live, and if you were to touch it, you'd receive a shock as the electricity passed through you and down to ground. So toaster is an example of Class 1. Class 2 means that the conductors are so well insulated, double insulated in fact, that extraneous parts don't necessarily need to be earthed. There's a way you can recognize a Class 2 appliance. First one is by a symbol. It's two squares, one inside the other, and I'll show a picture of that up on the screen now. But also, at least in the UK, the plugs, the top one there and the longest one, the earth pin, is actually made of plastic. Because earth isn't needed in the appliance, it doesn't need to be made from a conductive material, so it's made of plastic rather than just not having one at all. It's actually needed for the mechanism of UK plugs because the earth pin opens a shutter that allows line and neutral socket ports to be accessible. So you could either look under the appliance. I've got a Class 2 light here, but I've got some cables attached to it, so I can't flip it up. But on the base of this, there is the Class 2 symbol, as I showed earlier. And another way is by looking at the plug, and if you see the plastic earth pin, you've probably got a Class 2 appliance. Why those are good? Well, there is the on the one hand, there is a safety aspect to Class 2. You haven't got any parts that can become live. It also does allow you to have metal fixtures and fittings in a slightly safer design in certain aspects. But the problem with Class 2 is that if they do become live, if there is a fault, then there's nowhere for that current to go other than to pass through you or to pass through somebody that happens to touch it. On a Class 1, where all the extraneous parts, all the conductive parts are linked to earth, if ever a fault developed, that current would instantly pass from the live conductors to earth and create a short circuit that would trip one of your protective devices, either overcurrent or earth leakage. I'm going to make a couple of demonstrations here, including provoking a fault to show the seriousness of Class 2 when something goes wrong. But first of all, a little demonstration. So the light is working. I've got my MFT set up now with clamps just on the stem of this metal light. So if I turn it to conductivity, you can see that there is, when it runs the test, just a bit of a loose connection there. There is actually conductance between down the shaft of the light there, so current can pass through the light. There we are. That's a little better. No, I'm not getting a stable reading, partly because a round test surface is not the most reliable way to have crocodile clips. But anyway, you can see that current can flow through this device. Now, homemade pat tester here, inspired by David Savory. This is a socket that I've adapted to do pat tests where line and neutral are linked separate from the earth pin. And what I can do now with this device is an insulation resistance test, where we're going to take 500 volts. I had to unplug the light to run the test. We're going to take 500 volts and send it up through the live conductors of the light. Because it's going up line and neutral, I don't need to worry about damaging the bulb. If we go to 250 volts to start, what we're going to be doing is sending 250 volts up through the line conductors, and then with the crocodile clip on the stem here, measuring whether any of that current appears on the outside metal casing. So we're running the test now, and you can see we're off scale high at 250. Pat is typically done at 500, so I'm going to do that here now. And again, off scale high. So in normal status condition, the external conductive parts are completely separated from line conductors. There's no risk of current leaking out of the device. Now we're going to see what happens in fault conditions. I'm going to stop the camera now, make some changes to the lamp, and then come back and join you in a second. Okay, we're back now. I've set up fault conditions on this lamp. This is, by the way, an extremely dangerous situation. This lamp, even though it's working now, is live. The outer casing is energized to 230 volts. I'm going to show that for you in a second with my voltage meter. But what that means, if this was sitting on your bedside lamp, bedside table, you would see that the light is working. Everything seems perfectly normal. But if you touch this, you create a path to earth, and that current is going to pass directly through you. Hopefully your circuit has properly functioning RCD, which would trip before you had a dangerous shock, but there is a real risk here. So I've got a sink here behind me. I'm not sure if that's visible on camera, and even if you can't see the screen, that audible warning is telling me there's 230 volts now on the external casing of this lamp. Why is this particularly relevant for Class 2? Well, the same sort of fault could happen in a Class 1 appliance, of course, but a Class 1 appliance, like I mentioned at the start, because the conductive parts are all linked back to the earthing system, such a fault would actually create a short circuit path, and the current would trip your protective device straight away. Whereas with Class 2, because it's insulated, because the plug doesn't have a proper earth pin, there's nowhere for that current to go. So it sits charged up in this lamp, in this case, waiting for somebody to touch it to create a path back to earth. Okay, I'm going to leave that as it is for there, in the video. Switch this off. I think I have a healthy amount of respect and a little bit of nervousness around live unprotected electricity like I have in front of me here. If you've enjoyed this video, if you found it useful, please do like and subscribe. I do appreciate it. It really helps the channel to grow. Thank you very much. Bye for now. Hi everyone, hopping back on here. This is a day after I filmed the bit that you've just seen, because I realized while electricians watching the video would have said, okay, yeah, I understand all that and that's all clear, mate. Anybody else, probably all they heard was, metal lights are super dangerous, bye. Which is not my intention. We need a conclusion to this video. So I just wanted to come back and say, if you have metal lights and metal Class 2 lights are not by default dangerous items, and there is something that you can do if you want to make sure that they are safe, and that involves getting them tested by an electrician, either with one of these or with a proper PAT testing device. And that is someone that can take portable appliances. By the way, this is back to normal function now. I'm not risking 230 volts by putting my hand on it. But PAT testing is something that can take portable appliances like this and do the test that you saw at the start of this video, where they apply a voltage and make sure that it's not leaking out onto exposed conductive parts. When you have periodic inspection of the electrical installation of your house, or nowadays they're called EICR, Electrical Installation Condition Reports, they'll check all the Class 2 fixed appliances, so meaning lights, switches, etc. around the house, but anything portable isn't normally part of an EICR. But you can ask your electrician if they offer that service, or book somebody else to get these things periodically checked. They aren't going to degrade in a matter of weeks or months. It's over a period of years that things might start to go wrong, particularly if stored in conditions that aren't ideal. If they're wet, or sorry, humid, hopefully this is never getting wet. but in a humid environment or where it's subject to physical damage, if someone's pulling on the cord or if it's dropped, etc., that would be more of an occasion where you might start to see the insulation resistance starting to break down. But generally, don't worry, these things aren't dangerous, but they can be, and point of this video is to provide a little bit of education and make you a little bit more aware of that. Okay? Now I can conclude, I think. Hopefully everyone's happy. Thank you for tuning in. Thumbs up, please, if you enjoyed it, and see you again soon. Bye.